This video is going to cover some of the key problems you want to be able to solve for the logarithms benchmark. These are also on your review sheet for the logarithms benchmark. All right, so here we start off with some of our rewrites where we rewrite our um, logarithm equation as an exponent equation. And I'm actually going to start with number 6, our general case. Remember, the base of the logarithm is also the base of the exponent. Our logarithm equals the exponent, so whatever is on the other side of the logarithm is our exponent. So c to the p equals x. We're going to follow that pattern for all of these. So in number 3, our base is 9, our exponent is 9 halves, and that equals 19,683. Now in number 4, you're thinking, I don't have a base sitting there. When there's no number there, it is the number 10. So 10 to the negative fourth equals 0.0001. In number 5, again, we have no number, but for natural log, our base is e. So here we would say e to the 4/5 equals the 5th root of e to the 4th. All right, let's move on to evaluating logarithms. Remember, in ones like number 7, we're simply saying 2 to what power is 64. And recall our powers of 2. 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32. There we go. 2 to the 6th equals 64. But my answer is just the exponent, and I only write the exponent there. So now 2 to the 6th is 64. In number 12, we would say, well, 7 to what power is 7? And clearly that's going to be the first power. And this tricky one sometimes, 5 to what power is 1? Well, to get 1, we need the 0 power. Now that system of setting up equations is going to help us when they get tougher. So let's look here at number 17. We say 5 to what power is 1 over 125? Well then, let's see, move this one out of the way a bit. Now we're going to say, okay, well, let's see, 5 to the x is 1 over 5 cubed. 5 to the x is 5 to the negative third. There we go. X has to be negative 3. That's my answer, just the negative 3. In number 18, we're going to say 25 to what power is 125? We should recognize these both have a base of 5. 25 is 5 squared. 125 is 5 cubed. Notice when I wrote the 5 squared, I immediately multiplied that power by x, because what I really have is 5 squared to the x, but that becomes 5 to the 2x equals 5 to the third. And when I do that, then I've got my next line that says 2x equals 3. Oops, not 2 to the power of x. Let's try that again. That's an equal sign. 2x equals 3, and x equals 3 over 2. So our answer is 3 over 2. Let's try 2 more like that. 8 to what power is 1/2? We recognize that 8 is 2 to the third. We should recognize that 1/2 is 2 to the negative 1, which means 3x equals negative 1, and x equals negative 1/3. There's our answer. One more. 8 to the x equals 32. 8 again is 2 to the third. 32 is 2 to the fifth. That means 3x equals 5, and x equals 5/3. All right, now we're going to move on to ones where our base is those ones that we didn't see. Remember, this is a base of 10. So I've got 10 to what power is 1 over 100. We should recognize as 100 is 10 squared. Well, I've got 10 to the x equals 10 to the negative 2. Or I get negative 2. Here, this is just log of 10 to the 6th power, so my answer is 6. Notice it's just the exponent. Here I've got a square root, so I'm saying 10 to what power, and I should write this last one here kind of the same way we did the others. Let me go back. I'm saying 10 to what power is 1,000,000, and 10 to the x equals 10 to the 6th. Here I'm saying 10 to the x equals root 10. Well, what power is that? Well, that's 10 to the 1/2 power, so my answer is 1/2. The other one that a lot of people had difficulty was when we had log of something like 0.001. Now we have two options. You can think of scientific notation. What's the exponent there and how you move the decimal 3 places? You get -3. Or you can think of place value. So this is the tenths place, the hundredths place, the thousandths place, right? So we're in the thousandths. And if we're in the thousandths, that means that this problem is the same as the log of 1 over 1,000, which also gives us -3. So two ways to think of it. And then the e ones. Here our base is e. And we're going to say, well, e to what power is e to the 7th? Well, clearly x has to be 7, so my answer is simply the number 7. All right, now next we need to know our properties, and we need to know 3 properties: the one where we're adding 2 logs, the one where we're subtracting 2 logs, and the one where we've got a multiplication times a log. Recall that when we add 2 logs, it's the same as a single log with multiplication. So 8 times 2 gives me 16. This is the property that says log A plus log B equals log AB. In this next one, we're subtracting. So we're going to do 8 divided by 2, which is 4. And this is the one that says that log A minus log B is the same thing as the log of A over B. In this third one, we've got this as the power. And so 2 to the 6th power equals 64. That's what goes right there. And this is the rule that says that k times the log of a is the same thing as the log of a to the k power. All right, then we need to use those same rules to rewrite a single logarithm. Here we have addition, so we can rewrite it as a logarithm with multiplication. So we could multiply x plus 1 times 7. And we could just write 7x plus 1 and take the log of the whole thing. Or if we like better, we could say log base 5 of 7x plus 7. Both are correct answers. In this next one, we're subtracting. So we're going to rewrite this as log base 3. Notice the base does not change, of 2x minus 1 all over x. And you can put parentheses around that if it looks nicer. It's acceptable either way. In number 38, it's really 2 steps. These numbers here become exponents. So I have the natural log of x to the 6th minus the natural log of y to the 4th. And I can rewrite this one using division because it's a minus sign. Natural log of x to the 6th over y to the 4th. All right, I hope that is helpful in getting you a passing grade on the benchmark.